In this short video, I want to show you how easy it is to calculate critical values for a t-distribution. You're going to need spreadsheet software. Any spreadsheet software will do. You need that level of significance, and you need a degrees of freedom value. Once you have those, very easy to calculate the critical values. So I've opened a spreadsheet. We're going to look at these critical values for a t-distribution. I need to know my level of significance. So I'm going to put it right out there. Let's put 0.05 to start off with. I need to know the degrees of freedom. Every t-distribution is going to be slightly different, and its parameter is the degrees of freedom. So you will have to know that and type it in there. And then I need to know my alternative hypothesis. Is it two-tailed? Is it one-tailed in the lower tail? Is it one-tailed in the upper tail? So let's think about what these parameters are going to be. For this two-tailed alternative, remember for our critical value, we usually express the positive version of that. So that's going to be equal to 1 minus, and I'm going to click on this 0.05. So that's my alpha divided by, so that's /2, and that is of course 97.5. If I think about only this final 2.5% of the area under the curve in the upper tail, that means to the left of that critical value has got to be 97.5% of the area under the curve. So doing 1 minus alpha divided by 2, that's going to be spot on. Let's look at the one-tailed lower for my alternative hypothesis. So that's just going to equal alpha. I'm just going to go equal, and then I'm going to click on the 0.05, hit return or enter, and there it is, the 0.05. So coming from negative infinity, and all I want in that lower tail is the 5% least probable t values. If I think about a one-tailed alternative hypothesis in the upper tail, that's going to equal 1 minus, and now I'm just going to hit on that 0.05 alpha, which leaves me with 0.95. If I come all the way across from negative infinity, all the way across 95% of the area under the curve, that means there's only 5% towards the upper tail left. And that is that least probable 5% of t values in the upper tail. Good, now that we have these parameters, let's look at the critical values. So I'm going to say equals, and the formula is going to be t.inv. I'm going to open parentheses. I'm going to click on this parameter, 0.975, and then comma, I also need the degrees of freedom. So I'm going to click on that 30. I'm going to close my parentheses, and I'm going to hit enter. That's going to be 2.04. Now let's look at the one-tailed lower. I'm going to say equal t.inv. I'm going to open my parentheses. I'm going to click on the 0.05, comma, the degrees of freedom is at 30. Close my parentheses, hit enter, and I see negative 1.697. And of course, in the upper tail, that's just going to be the positive of that. But let's make sure that's going to equal t.inv, open parentheses. I'm going to click on this parameter 0.95, comma. As you can see there, it says degrees of freedom. I'm going to click on the 30. I'm going to close my parentheses. I'm going to hit enter, and there's my positive 1.96. So let's change this degree of freedom. Let's change it to 100, for instance. And I'm immediately going to see that update. Now it's at 1.98, negative 1.66. Let's change the levels of significance. I'm going to go 0.01, and I see now those values get a lot bigger. So that's how easy it is to get these critical values for the t-distribution.